Hey everyone, Zach, congrats on the first. Eldritch Hate, Thunder Hate. Okay. Is YouTube stream going? Okay, good. It's like Thunder off the rip has a question here. Oh no. Oh god, you're gonna hit me with chemistry? Oh, okay, okay. I'm a little scared, but I see you sent the answer too. Maybe I'm just gonna put the answer up because this looks scary. It's fusion. Okay. You are the unanimous first. Chemistry is just applied physics. Easy. True. Okay, deuterium-tritium reaction is a nuclear reaction between two isotopes of hydrogen. Okay, fair enough. One second, my cord is kind of tangled, and it's. I thought I could just. Oh. I thought I could ignore my cord being tangled, but I can't. And then in the process of untangling it, I dropped my stylus. There it is. Okay. Okay. Deuterium, tritium makes whatever the times 4 plus a spare something. Neutron, I guess. Each of this reaction is transferred to the kinetic energy of the helium nucleus. Okay. Show the kinetic energy of the neutron represents approximately 80% of the total energy transferred. Really? What? Okay, so I see it in the answer that's saying something about the mass, and I was like, okay, yeah, if we can somehow show that a neutron has 4 times the mass of this isotope of helium, then we'd be in business. But like, doesn't helium? Isn't it going to have at least two neutrons in it, or maybe one? Oh wait, no, that's perfect. Okay, I have it backwards. Yeah, so proton neutron way roughly the same, right? Dude, my world got messed up when I learned that a neutron is just a proton with an electron stuck on it. But Bobos, hey, hope that the conference is going well. Yeah, right. That make does that make sense? But why would the thing that weighs less get more kinetic energy? They would have different velocities. What is that formula? E squared over 2m. Yeah, Thunder. At least as far as I remember. Neutron. Wait. What was I lied to? What? My world is coming down a second time. Is a neutron a proton and an electron? I was lied to. Hey, Ben. Wait. The answer is false. Okay. I was... God damn it. I'm done. I'm done. That's the end of the stream, guys. I'm done. Oh my god. Okay. Okay. Anyway, hey Lucas. Well, Ben, blame thunder. Steinmetz solid, welcome in. When the reaction occurs, the atoms combine, then eject a neutron. I think that might account for the energy difference. The helium may not be moving as fast as the neutron because most of the energy of the helium was forming the helium in the first place. That's just intuition. Okay. Welcome in, by the way. I already said welcome in, didn't I? Yeah, that feels like it makes sense at least. You finally realize why you like math more than other subjects? Why is that? It's way less memorization than other subjects, like biology is a bunch of... Yeah, I feel the exact same way, Lucas. I hate having to memorize stuff. I thought I liked chemistry until I took a chemistry class and I realized how much memorization it is. Why? What is the p squared in their formula here? Kinetic energy from chemical reaction formula. P squared is momentum? That would make sense. Rho's momentum, okay. Material science was a... Oh, it's rho, okay. Material science is a pain when I was studying engineering. It sounds like a pain. Oh, wait. Oh, that's just... Oh, that's fancy. Okay, never mind. That's the kinetic energy formula that I already know then. This is the same thing as 1/2 mv squared. I just have never seen it written like that. Yeah, if you go deeper into physics, like the electricity magnetism stuff that I've been studying, it's less memorization, or like you kind of build it the same way that you build math. So I really enjoyed that. But the way physics gets taught to people who are new to it is all memorization, and it's annoying. So I didn't really like physics in any of my classes until I studied it on my own. Using p squared over 2m for kinetic energy in the first part of modern physics. Show the kinetic energy of neutron represents approximately 80% of total energy transferred. So the kinetic energy, okay, so they're making a point that they have equal and opposite momenta. So that's rho. Rho of 4-2he is equal to rho n minus rho n, I guess, ignoring the sign. But we're about to square it anyway. The kinetic energy Oh, yeah. Okay, okay. The kinetic energy 4-2 He is equal to its momentum squared over 2 mass of 4-2 Why is it equal to the negative and opposite momentum? Because momentum is conserved. They start with 0 momentum. They say kinetic energy, but I think that the same thing is going to be true for momentum. And so they must have the equal and opposite momenta. Because they started with 0. I hope. Okay, and so we can say this thing here is minus rho sub n squared over 2. We can say that this thing here is 4 times the mass of a neutron. A negative squared becomes positive on top, so rho sub n squared over... I'm going to write this in a weird way. I'm going to write it... I'm going to bring this 4 out front. So 1/4 times rho sub n squared over 2 m sub n. And that's just 1/4 of the kinetic energy of the neutron. And so this is a more formal way of this first statement here. Do you see Tutopi's question that's about the number? Oh, that was like Wordle. I was listening to the discussion. I wasn't actually... I didn't actually read the question, though. The negative, it was squared, so it just became positive. Yeah, I basically, like... Zach's citations are a little bit, like, early for me. I often have them up on my phone while I, like, do my morning routine and stuff, so I'm not able to follow, like, that closely. No worries. I'm glad I was able to figure this out. Do you understand why the 1/4 correlates with 80% though? I guess I'm not really asking you to explain like that part that much, but it's all what it's like having some question you set up an inequality, but the inequalities don't exist. Oh no, okay. Okay, yeah, good. All right. Well, thank you for the question then, Hunter. Let me know if you have any more. Lucas, you're good at that question you posted before, right? If you have anything else, feel free to let me know, but unless I hear something from you guys, I'm gonna do some studying, I guess. You do have one question? Okay, yeah. Let me know. Eep. Oh, from that one? I didn't see my work, unfortunately. Let me... Are you guys on a specific line of what I wrote? Oh, I do have... I can put the image. Oh, in general. Uh... it's a really weird number. It doesn't mean anything special. If you want, you could write it like this, because a negative exponent means you put it into the denominator. And if you really felt like it, you could get a common denominator. Hey Rex, how's it going? So you could write it like that too, but like it's just kind of weird. It doesn't mean anything all that special. It might be more helpful to like plug things in for a. So like if a equals 3, that's 3 to the x minus a third to the x. But, you know, that's just a number. Yeah, famished. Yeah, it's weird to deal with this sort of form. Like it's kind of just like I had to stare at your question for a while before I understood what to do, because it's just kind of a difficult thing to work with. So I don't know if that answers your question, but I hope that does. The source was a math test, yeah. State math test or something. That makes sense. I was like, I had the complete wrong idea for how to solve it, and I was just staring at it, wondering why it doesn't work. Doing an algebra speed run. Ooh, good luck. Ugh. The Chads here are the real deal. From 8 a.m. now it's 4 p.m. Oh my god. Gonna do a few more, alright. Doing it like it's a full-time job. Alright, let me pull in a physics question here. The sum of the odd numbers from 1 to 19, that's a formula. You're also gonna do some studying? Alright, sounds good. I think that has like a pre-made formula. I don't remember it though. Let's see if we can figure it out. A helpful thing to remember is that the sum of all the numbers 1 to 19 is 19 times 20 over 2, which is 190. If we can figure out what 2 plus 4 plus 6 plus ... plus 18 is, we could subtract that out. Is it 100? Rex is the true Chad. I mean, we could say this is the same thing as 2 times 1 plus 2 plus 3 plus dot 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 plus 9. And using the same formula, we could say it's the same thing as 2 times 9 times 10 over 2. Oh, which is 90. So we have 190 minus 90 is 100. There you go. Not the quickest of math, but I'm still taking those points. Yeah, yeah. I think there's a more direct way to do it. Or I feel like there's a formula you can make to directly get to the odd numbers. N equals 1 to k of 2n minus 1 is equal to k squared. Oh, and so k would be 10. Interesting. Okay. Hey, FabSab, can I help with physics? Barely. If it's a relatively basic physics question, I can. I was about to try and work out what the formula would be, but now I'm getting lazy. Yeah, I'm trying to learn more physics for myself here, so I'm actually about to pull one up and see if I can do it. You hold the handle. You hold the handle of a bucket of water and swing it around in a vertical circle, keeping your arms straight. I don't ask why you would do that, but apparently I'm doing it. Swing arm fast in the water, stay inside the bucket, even at the highest point where the bucket is upside down. What roughly does fast enough here mean? Specify the maximum time of each revolution. Whatever assumptions you want to make for the various parameters involved. From working the approximation, the speed of the bucket is roughly constant throughout the motion. Is there ice in the bucket? True. Are we doing some sort of challenge with the ice bucket? Who is that? Oh, Submet the Turk. I've heard Stookie talk about him. What's actually happening here? So we need to remember the difference between the different circular motions, right? They both start with I. Or no, never mind. Centripetal versus centrifugal. Why did I think they both start with I? They both start with C. So we probably want centrifugal. Gotta walk the doggos? Alright. Why don't we talk about that? Didn't we talk about that somewhere? Did we talk about it in this chapter? Okay, what was that? Okay, there's a multiple choice question with a plane. And I remember it very distinctly because I was on a plane to Japan as I was solving it. Like, oh, hey, this is appropriate. This one, number 17. I don't remember which one the answer was, but if it was E, that might help explain. I don't think it was E. Let's just see what the answer was, though. 17. C. Okay, well, that's not that helpful then. Well, okay, like, when the bucket is at the top, what are the like what there needs to be a force that's acting upwards on the water, right? I can't figure out what that force would be. Papa Dory just put a question in YouTube chat. Find integral from 1 to 2 of fx dx. Ooh. That could be interesting, Papa Dory. Let's think about that. And Myron, the average person walks the equivalent of about 5 laps around the Earth in their lifetime. That's kind of cool. I bet that varies a lot by like where you live. Huh. Interesting. Is it worth considering that the integral from 0 to 2 of f of x is equal to the integral from 0 to 1 f of x plus the integral from 1 to 2? this quantity we're given. This one, maybe we can use this fact up here to work something out. Rex agrees. Okay. Am I doing masters? No, not right now, Race. I'm applying for one though. Because this is probably dangerous, but I think we can make some type of statement, like also the integral from 0 to 2 f of x dx is equal to twice the integral from 0 to 1. But there's no way, I don't think this can be exactly true, or we need... This is sketchy, but I want to do something like this. But the thing that confuses me about that orange hue is, isn't mv squared over r pointing radially inward? Or am I misinterpreting that? Oh, really, Steinmetz? Okay. That makes sense. Found the answer, Marcus, method of finding it if you want. For now, it's okay, Papadoria. I'm interested to see if I can figure out how to get this myself as well. I'm glad that you know what the answer is, though. What? So wait, actually, what does f of 2x do for an integral? So f of 2x, it should be a horizontal... compression, right? Which means your integral needs to go farther out. Can we actually make that statement? Is it true that 0 to 2 no, I guess 0 to 1 f of x dx is equal to 0 to 2 f of 2x dx? Is that just like a general statement we can make? Let's... Yeah, I feel better about this now. Yeah, right, it's a compression by half. I think this is the realization that we needed to make here. Because we can plug it into the left side here. So... Oh, wait. This isn't the exact thing. This is a 2x. That's just an x. Wait, I have this backwards, don't I? Did I write this slightly incorrectly? No? Yes? Yeah, I think the 2 goes on the other f of x. Let's do a simple function just as a test. Does 0 to 1... Wait. If I say f of x is equal to 2x minus 3, does 0 to 1 4x minus 3 dx equal 0 to 2 2x minus 3? This feels wrong, so why isn't the 3 getting adjusted? Let's just try it anyway, though. 2x squared minus 3x, 0 to 1. X squared minus 3x, 0 to 2. Okay, there. They're off by a sign, right? That's not good. No. I don't know how to do math. Well, okay, they're still wrong. So maybe... So did I have it right the first time, actually? I don't feel like I... They're off by a factor of 2. The above we should use u sub. Oh, a u sub is... Okay, yeah, that's a much... That's probably a much more direct way of thinking about this, isn't it? If we just take this integral, I guess, and do a u sub on that, u equals 2x, du is 2 dx. That means 1/2 0 to 2 f of u fu du. Yeah, Papadoria. We definitely need some kind of adjustment thing in order to make some type of relationship like this work. Why do people in Cali boil water to make a cloud? Wait, what? I am using a humidifier right now, if that's what you mean. But I feel like I don't know what you mean by that. You get -3 syntax error? Oh, whoever just boosted the server, thank you. I can't actually see them in streamer mode, but I appreciate you. Oh, where the fire is? Probably because something got into the water, or like, usually do that to purify it. I assume maybe some pipe got like contaminated. So how, like, if I want to come over here and use the same fact, am I going to say you made a mistake? Oh, okay. I am in California, but I'm very far away from the fires, so They're not affecting me. Do we want to do this? I feel like I'm doing something slightly wrong and applying it to this thing here. Let me keep trying to figure this out, syntax. Ugh. Yeah, meme shooter. It's from my favorite video game, Fallout New Vegas, where the world's been nuked, and one of the new countries that was set up is the new California Republic. So we do have you here, but I think we're still allowed to use this relationship up here. So 3 to 2, 0 to 1, f of u du. And I assume for the same reason we can also use this fact up here. So I'm not going to match what syntax error got. Oh, you're saying 5 or 6 is wrong, though, Papadoria. Okay. So I'm getting 1/2 with my technique here. Is 1/2 right? Oh, wait. No. I take that back. That's not 1/2, that's you. Or that's not 1/2, that's 2. You. When I actually wait. That becomes a 6 there. 6. I guess I'm getting 5. I haven't heard that song. It is 5? Okay. Okay, wow. I could try and explain that better then. What an interesting problem. Let me drag this out of the way, because it's annoying me how cramped my work is right now. Okay. We start by considering the integral from 0 to 2 of f of x. And that only came to mind to me because you can break up an integral into a 0 to 1 piece and a 1 to 2 piece, and 1 to 2 matches with what we want to eventually find. The first 0 to 1 piece, we can just plug in directly using that fact. So we get a 1 here. The remaining task and the biggest task of the problem here is how to deal with the integral from 0 to 2 of f of x dx. And you can force it, like, the thing we haven't used yet is this fact here. And so this is a problem on a homework, so we know we're probably gonna have to use that fact somewhere. So we can force this integral to have a 2 or inside the f of x, so that we're able to use this fact using a u sub. So I made x equals to 2u just so we can get a 2 inside the parentheses there. Fix a problem when you flopped your arithmetic. Oh, okay. So once you do the u sub, you get a factor of 2 out front because of the dx equals 2 du. And then the x inside the f of x becomes a 2u. Great. In the next step, I brought the 2 out front, and I applied this identity here, because even though we have a u, not an x, it's just, I think you would say it's just a letter, and it doesn't actually matter. This property still holds. So this f of 2u became a 3 times f of u. And then that 2 times the 3 from there became 6. And now we have the integral from 0 to 1 of f of u du. And I think by the same logic that u is just a letter, you can use this fact again to get 1. So you get 6 times 1 is 6 is equal to 1 plus the integral that we want to find. So subtract 1 to the left side and you get that 5. So I hope that makes sense. We do the same thing in reverse. You start with integral from 0 to 1, transformed it into integral from 0 to 2, then split. Oh, okay. Yeah, Papadoria. I was really spitballing here with like like I was just doing this by feel and kind of trying things, and it happened to work out here. It's a neat question. Thank you. And thanks, Lubert, as well for the shout on the use of. Okay, let me revisit this bucket question. And what were people putting in chat before? So there's two forces, mv squared over r and mg. If g is greater than v squared over r, the water falls. There's no upward force acting on the water. The theoretical idea is that the velocity of the bucket causes it to be under the water before it can fall out of the bucket. So the velocity divided by the radius needs to be greater than the acceleration to allow for this to happen, as Orange said. Velocity is squared over the radius. Really like these function things. I don't think it's emphasized nearly enough in school. To be honest, they're not my favorite. 'Cause I don't know how it's useful, I guess, and that's what makes me like enjoy certain things in math. It's neat that we can shove the numbers around and get something that works, but I wouldn't say they're my favorite problems. The velocity bucket causes it to be under the water before it can fall out of the bucket. So mv squared over r looks familiar. And it looks familiar because it's the centripetal force. I guess it sounds the most like useful stuff. You're able to describe the quality of something to be able to derive other properties is kind of cool. Yeah, that's fair. If it was attached to like an actual like real world situation or like some kind of like physics situation, I think I'd like it more, but I can see how something like that could be like actually useful. But I want to know like where it actually does happen, I guess. Um, so it is a stick man. It's me tossing a bucket or I guess swinging a bucket in circles. I want to draw it at a different point though. Maybe like right there. So radially inward, we have centripetal force. And always down, that's not down. Always down, we have gravity. Donda's art confirmed. The force is strong enough to break. Well, I think we have to consider that, but yeah, at some point, I assume the handle would come undone from the bucket, or my arm would come undone from my shoulder. You know, that's always a fun possibility. I guess I should have two arms, not just one arm, right? Also, I don't know why my chin is so droopy. Please don't make fun of me. I'm very sensitive about it. And so what Steinmetz and Orange were saying, okay, no one will mention it yet. Thank you. Is basically that the velocity of the bucket, like when the bucket is at the top, the water is going to start falling down, but the bucket comes back around fast enough that it basically catches the water in time. That looks that what I just drew in the bottom there does not look like a bucket. Let me get that off the screen. Yeah, it's physics famished. And so I'm trying to figure out what am I trying to say? So Orange and Steinmetz were saying that this relation must hold in order for the water to not fall out, and I'm trying to justify why. Ben 10 Somniverse, thank you for the follow. Or Ben 10's Omniverse? I don't know. Either way, thank you. Let fam draw me. I don't think Don wants... Wait, who's drawing who? Waffles, that sounds good? Waffles always sound good. the page. Why would this have to be true for the water to not fall out? If you want, you can draw me. I don't care. I don't know how you look to be able to draw you. No, I used to let people choose something for me to draw. So if you scroll back up high enough in that art channel, I would post the drawings that I made in there. But ever since I switched from the whiteboard to like this electronic thing, I turned it off because it just like doesn't really feel quite the same. Or it's not as much fun. Like drawing whiteboards is just fun. On the Seno. Or it's fun. Is that a hobby we might have to pick up in the future? You have many hobbies. Okay, you know what? If we just follow this through, isn't v squared over r that is similar to angular velocity, right? Or something like that. It's not the right units, is it? Angular acceleration. Or radial acceleration. Not angular. But v is equal to r omega squared. There we go. Wait, omega squared. V is equal to r omega. That's what I want. So exercise your right brain. Try to draw with your left hand. Draw with my left hand. I can't even draw with my right hand. Unless you mean famished. Hey, Obi. This program here is Journal++. I don't know if that's what you mean though. Hey, Fembox. Notepad++. Oh yeah. I mean, I don't think you can draw on that, right? But I'd definitely use that for like if there's like a game I want to edit the config file for or something. Same people? Oh, I'm not sure. Not as far as I know. I think they're, as far as I know, they're different people. I think they're both open source though. I like this because at some point it's one of the things that I keep like saying I want to do and then not doing. I want to write a plugin for this at some point. Do not mention his stick man chin. You just mentioned it. Yeah, Hamish. What the heck? I'm very sensitive about my chin. You know what? I'm gonna grow a beard just to cover it up. There you go. Can't even tell. So I guess I have the answer to the question there, but I'm still having a hard time justifying that step. Why that must be true. You make a Don Funko toy? I remember you posting. It was you posted like Funko like things for me, haven't you? Hmm. F is MR omega squared. My reaction when do people? I don't think people still say MRW. Heart physics dedication. I feel like I'm half-assed dedicated to it. I've been on chapter 4 for multiple months now. Okay, well, let's just look at the solution, I think. I still can't really come up with a justification for that step, but it's number 19. At some point soon, I'm going to move on to chapter 5, right? I can't spend forever on 4. Okay. Consider a little volume of water with mass m, assuming the water stays inside the bucket. Top of the motion, force on mass m are both downward. Yes. Well, the downward normal force from the water. Oh. Okay, that's an interesting... They're considering just a little bit of the water inside the bucket. Oh! Okay. This F equals MA makes a lot of sense. How are we going to use that, though? If V is large, then N is large. The cutoff case for the water barely stays in the bucket occurs when N equals 0. What is page 108? Myron, the book is Problems and Solutions in Introductory Mechanics by David Morin. It's a really good book so far. It's really hard, but it's very well thought out. Does this make me happy? All these fancy math concepts can be used in reality? Yeah, Rex. I enjoy math much more when I know the motivating problems behind what I'm learning. Fall season 2 is being affected by the fires in California. Oh man, that sucks. Watching a biologist swinging DNA solution in a tube to separate DNA. Really? You should have to try and explain the rules of the game we all find ourselves in. Yeah. Oh. I guess so. I still feel a little bit sketchy about taking n equals 0. Oh, I guess my answer was in radians, wasn't it? It wasn't going to get released until next year anyway. He's in Africa studying monkeys and had no equipment, so he improvised. Wow. Guy sounds like MacGyver. MacGyver with 3 M's in front because I freaking stuttered. Ugh. Okay. I like this remark here. He tied the test tube on a string. Oh! I was imagining some very precise machine, but I guess yeah, you're right. Wow. Yeah, that does work, doesn't it? Because like in general, if you swing something around in a circle, that separates things out by the density, right? Like the densest thing will go to the outside. They are, yeah. All right. You're a wizard, Harry. Hey, Ren. You're a hairy wizard. Hey, Cytos. It's a natural centrifuge, yeah. How many more of these problems do we have in chapter 4? Through 25? I don't know if we'll do all these, but let's at least look at 20. Or maybe I will do all these because they don't involve Atwood's machines. A plane and a holding... Oh, I want my free $0 back. There's a typo. Pattern. A plane and holding pattern flies at speed v in a horizontal circle of radius r. At what angle should the plane be banked so you don't feel like you're getting flung to the side of your seat? At this angle, what is your apparent weight? Oh god. The normal force from the seat. Really? So, okay, from the top down, our wow, why is one wing bigger than the other? It's like Nemo. This plane is like Nemo with like one fin bigger. It has a tangential velocity v, right? Radius r. And so the plane is experiencing 3 forces, right? Centripetal. Well, maybe we don't want to... Do we want to think about that? let's just leave it there for now. Some upward force, I assume the plane is exerting. F plane, and a downward force from gravity. And so it's this centripetal force we need to somehow balance. Right? Ren, pop quiz. A relation is a relation between two different numbers. Technically true. A relation is a relation. That's a logician's answer. A tautology is a tautology. So what's happening when the plane rotates? With that logic, I know everything. You do know everything, Ren. Yeah, Ren in the house. I think a hard time imagining what's happening as you are in your seat. We probably don't have to care about the vertical forces, to be honest. We know m v squared over r is the... It is going to involve gravity, isn't it? Okay. So maybe what we're doing, oh god, how do I draw this? If I draw a cross section of the plane, and we tilt it, that's the floor. Trust me. That's the back of a seat. Only one seat in the entire row. Can you believe it? What we're basically doing is splitting up gravity, right? Because gravity will have a component going down and a component going, well, going to the left, I guess. In the centripetal force for the plane is pointing inward. But am I feeling an equal and opposite force going outward? Because if you're turning left in a car, you move to the right. Right? I think that's what's happening. So like, that's centripetal. That's FG sine or cosine something, and that's FG sine or cosine something. It's like the scene in the plane you took 3 weeks ago. If you were the only one in your row, that's a magical thing. And I guess we can define theta relative to the horizontal like that. Oh, I freaking hate working out theta in cases like this. Yeah, just fly business, friend. What are you doing? Gotta shell out. You only fly first class? Hell yeah. You don't have any more money? Wait, I'm still not thinking about this quite right, am I? I think I drew my arrows for gravity in the best way I could. Go earn some by doing tap dancing? If it does the trick. So this is weird, like yeah, the tap dancing business is booming, eh? Like, hello, my baby. Hello, my darling. Or whatever that song is. We're trying to balance a force going that way. Gravity, we can break up into components tangential or normal? I forget. I don't remember. And parallel. Uh, but this, like, I'm wanting to break these components up a second time now for gravity. Is it better to break up centripetal? Maybe that's the answer. Break them until they're only atoms. Ugh. I stop. I want to select that. No. That. No. That. Thank you. So maybe we actually want to do this sort of thing. There needs to be a force to lift the heavy junk up in the air. That's been in the back of my mind where like the plane is experiencing, it has the upwards like thrust force or whatever. I'm just kind of ignoring that, to be honest. I'm on the right track drawing the FBD from this perspective. Okay. That's good to hear. Now what? I guess we can work out what our trig is going to be. And I always get confused on this bit. You draw a triangle like that and like that. And that angle right there is theta, right? And so... What did I... Oh, I scrolled. Watch me zoom out in my chair. I remember when I was in high school, I was really into League, like League of Legends. And I sometimes got so excited. I think it's happened twice. I got so excited and I was so like hype and bouncing around that I actually fell like backwards in my chair because I completely toppled over. But the game was still going, so I just like picked my chair right back up and got into it again. And like both times my family were in the room and just like looking at me. Like, what the hell is he doing? I'm 27. This is sine theta, right? That's cosine theta. Six years older than you? Oh, okay. Wait. I'm not drawing a centripetal force right, am I? Does the arrow... Wait. Does this arrow... Should it be pointing the opposite way? Yeah. Yeah, it should be. Ugh, that... messes with a lot of things here, though. And I hope by the same logic... Is it the same logic, though? Ugh. Does this book draw centripetal force in examples? That's a good question. Yeah, sure, Papadoria. Go ahead and send it. It has 2 paragraphs total in centripetal force. Its main thing is that it points radially into the center. And so I'm taking the force on me to be radially outward. And then if the plane tilts, we can break that up into components, was my idea. It does give the free body diagram in one of the questions for basically the situation here in 17. It says the answer is C. I think. Yeah. I think is the best that we're gonna get. Oh yeah, yeah. The person I just responded to was Papadorio over in the YouTube chat. Let me make sure it was C. Yeah, C. I was mentally splitting up. They combine centripetal and the air. I guess the air is providing both forces, isn't it? I was ignoring the upward component of the force from the air. I'm assuming in all parallel universes? True. Is that a bad idea? Should I be considering the upward force from the air? Oh, maybe. There was a net force along the radial direction rather than actual force. Okay, fair. I think that came up in number 19, where you don't actually... It's more of like... Oh, frickin'... I hate when Journal++ does that. I don't just... it's probably more OBS's fault, but I don't know why it does that sometimes. Oh God. Okay. Let's take a little break from this question. Look at Papadoria's question. Let f of n equals 2n plus 1 and g of n equal 4n. Let s be the set of positive integers that can be achieved by doing a combination of f's and g's to 0. How many positive integers less than or equal to 1024 are in S? How many positive integers less than or equal to n, where n is a natural number? What is the... I don't know what the 2-0 part means. For example, f of g of f of 0 is one number in S. Oh. Okay. So n equals 0. Oh, hey, Hamish. Yeah, it does mean evaluated at 0. Interesting. So positive integers. So I guess we have to start playing around with this because I don't really have any intuition here. We know if we take just f, we get 1. So that's an S. G of 0 is 0. That's not a positive integer. So any composition of f and g. Okay. Yeah. I think I get it now. And so I think we can eliminate any composition that ends with g of 0, right? Does that make sense? Yeah, because you do g of 0 first. No, you just get 0. Never mind. You can have it. It can end in g of 0. You can't get 2. Yeah, that seems like it makes sense. So what is g of f of n? Not plugging in 0 yet. 4 2n plus 1 8n plus 4. Can't get 5 or 6. Okay. So if we keep doing G's and hustlas, we just keep smacking 4s on the outside here, right? So we can get powers of 4, right? By this logic, 4 to the... maybe 4 to the k belongs to S, just for some k. Cytos, what's unclear about the question? Like, by composing f and g evaluated at 0, how many positive integers can you get that are less than or equal to 1024? Oh, 2-0 means evaluated at 0. Sorry, yeah, I should have started with that because I had the same question. 1024, that isn't that 2 to the 10? Yeah, because 2048 was the popular, phone app. Got some good scores, I bet. One of my friends told me that the technique is just to always go down and to the left, or just always do the same two directions, and then you only rarely need to deviate from that. 16,384. Wow. At that point it's like it takes a lot of time to do that. It gets kind of grindy. To provide the answer, you got confused on how to get it. Yeah, it's going to take a lot of playing around, I think. What happens if we go the opposite way? If we do f, I said this wasn't interesting, right? F of g of n, 8n plus 1. That doesn't give us anything unique, right? Can we make the statement? No, we can't. Can we can we make some statement about like as soon as you have an f of g somewhere, you're not helping or you're not going to get anything unique? Like I feel like there's some arrangement like this where you just know that anything beyond it isn't going to help you. I haven't quite I don't quite know that though. Maybe it's a mod 2 problem. Maybe. This feels like some foundational problem for like an abstract algebra class, to be honest. So what happens if we do f of f? I think that's a worthy thing to investigate. Because we're getting what are we getting? Four n plus 3. Okay. And so using the same... Actually, no. Let's keep using just f for now. That's where... I think you already did this fembox, right? Because you're saying you can get 5... Or it's like you figure out how to get 3. Is that how that looks? I think so. So that's 8n. Ugh. 3 times 2 is 6, plus 1 is 7. Okay. And so if we do one more level, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Ugh. We would get 16 and is this good? I hope it's gonna be 11. No, it won't be. Ugh. Oh wait, can I use the thing that I can say to 8n plus 7. I don't have to do those super complicated nesting, right? 15. What does that mean? Ah, sorry. A binary problem. How would binary help us here? One plus one means binary append 1. Oh. And 1024 in binary is 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? 2 to the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, okay. Say something in English, like 2 lines any English actually. I want setting on the live caption. Do not mind that I am deaf. Sorry, but a little. Oh, yeah. Is there a setting that I can turn on too? Or um let me make sure there's if there's a setting on my end. Seems like live caption is not working. Oh no. Ah, no, I wrote 2048. Oh, I did write 2048. It should be 1024, I'm sorry. Um Sorry, someone's asking for live captions, and I want to. Oh, it's because of the. I just have the wrong stream settings for YouTube. I have to make the wait and see. On YouTube, I stream on ultra low latency, and apparently that doesn't support closed captions, which that's kind of sad. I can change that though next time I stream on YouTube. I just can't change it while I'm live. Oh, interesting. Change of base. Yeah, Papadori, I didn't think of that either. How are the math streams on YouTube? I think Twitch does a little better than YouTube. Yeah, Twitch has a much... There's some really cool people on YouTube too, but I think in general Twitch, I prefer the community on Twitch. It's a bit bigger and people are a bit more like social. On average. Any binary numbers or representations I made of 1 and 0 in any combination. Just no number with any zeros occurring alone. Actually, no odd count strings of zeros. Oh god. Okay, so I can see why you can't get 2 in this binary construction, because f of 0 is equal to 1. And if you do f of 0, you get 2, right? I guess I should call it 11 if we're working in binary. Sorry, 3. God! And your other option of using g instead would give you 100. Okay, so I see where you're coming from now with, you can make any binary number you want. As long as any string of zeros is even. What a terrible T and R. Oh my god. I really phoned those in. Functions are always increasing the smallest possible numbers 1, so find the function that 1 gives 2. 2 is not possible. I think we look at cases for amounts of... It might be small enough that we can do this in cases. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if there's 9 zeros, there's only one case, right? Um, 0, 1. Oh my god. 1, 2, 3, 4, 5, 6, 7, 8. That's the only thing we can eliminate with 9. Or no. Wait. I need commas. There. Okay. Wait. Why don't these match up? I need another 0, don't I? There. And then with 7 zeros, we have options, right? So we're chopping off 2 zeros. Oh, that's kind of hard. So wait, if we have 7 zeros, and we only want to count things that start with 1, right? We're chopping off. That's 10 digits. We're chopping off 2 of them. So we're gonna have 1, 2, 3, 4, 5, 6, 7, 8 spots. We're only interested in having a leading 1. We know we have 7 consecutive zeros. The rest could be 0. No. This is a little bit too hard, I think. Wait, if you have a string... No, I'm not... We do need all 9 slots. A leading 1 there. So if we had 7 consecutive zeros, 1, 2, 3, 4, 5, 6, 7. One, as long as... Well... This song is kind of a banger. It's not as good as the song, but I kind of like this one. Yeah, Papador. I'm starting to hit a wall with this method anyway. This counting problem is not as easy as I hoped it would be. There probably is something to this binary approach. My engineer's study blog. Oh, thanks for playing on Twitch as well. $144 is the answer. That seems... I thought it'd be a lot more than that. I love the thought, Fembox. There's probably something to this. But doing counting for all these cases seems a little bit difficult. Yeah, we need to pass this off to Stuki. that whenever I see anything combinatorics, that's always my vote. Just make it Stuki's problem. Hmm. And Agri PPA05? Thank you for the follow. So I feel like with this approach here, I feel like I'm kind of onto something. If we like, what's the pattern for starting with 3? You take the previous number, multiply it by 2, and add 1. Like, I'm gonna shift the binary stuff down because it's a neat idea, but I'm not sure where to go with it from here. Like the pattern, like, because we can take all these numbers and keep multiplying them by 4. Yes, Eidos, that's what Fembox was saying. How do you solve a recurrence relation? I feel like I should know that, but I don't. Like this connection with polynomials for some reason. But yeah, I'm kind of thinking that like, well, no, I don't even know if this is the right idea. I think that you can continuously compose f to get kind of base numbers, and then start continuously composing g to get other numbers. But if I do like that, might not be right because we can always mix in stuff too, right? It's like 12 is a new number, so I don't think that there's much to my approach. Well, have we covered 12? No, we haven't. This is a tough one, Papadoria. I gotta start sitting crisscross applesauce now. Idea would be to change 1024 to a smaller power of 2, try and work our way up and look for a pattern. That could be a that could be a good idea. Like, what if we just did like 8? Small but not completely trivial. I'm going to copy the problem and go to a new page just so we can do some separate work here. Let's pretend that's 8. So we all agree that we can make 1. We agree we can't make 2. We can make 3 with f of f. turn into a combinations problem? Yeah, it's a good bet. Can we make 4? I feel like we can't. No, I don't think we can make 4. No, wait, I said 4 to the... We can make 4. G of F. I literally did it earlier. Can we make 5? Then Lexi said this one earlier. I think we can't make 5. Yeah. 6, I think we can't make 6 either. Seven we can make. I did that earlier. It's 3 Fs. And then 8 we can make. G of F. No, that's 16. Can we make 8? Maybe we can't make 8. Because we can't make 2. So that's some kind of Fibonacci-like thing happening. Oh, that might be a simpler way of boiling down the combinations problem, Cytos. Think of your blocks as 1s and double zeros. I was doing the reverse problem of eliminating the wrong ones. Yeah, right, I agree. My engineer study vlog. This is 1, 2, 3, 4. So if n equals 8, the size of S is 4. We do have to answer generally for natural number n, but let's keep it to the powers of 2 for now, maybe. So what if we go to 16? Can we make 9? I'm thinking no. Can we make 10? I feel like I'm not being imaginative enough, but I feel like we can't. 9 is f of 4? We're only allowed to plug in 0. Like, we can never do f of 4, right? Oh, wait. Oh, I'm sorry. You mean we can get 4 so we can get 9? Oh. You're okay. Yeah, good call. Good call. F of, so I would take this 4. Right. And put an F around it. So I should be using these more. maybe. It's the lesson. Will you say an AMD build is better than Intel? I've heard that Intel is having issues recently. I don't really follow PC parts much. Or like my knowledge of them is pretty limited. But I think it might also only be certain Intel cards. I don't know though. Can we make a statement like an even number must be a multiple of 4? No, because that would break it if that's true. And is under 8 or equal 8? For the first one, yeah. I'm making up my own examples here. So wait, so for, I think 10 is an even number, so F will never help us get to 10. An even number should have even power of 2. That's probably the statement that I'm looking for, Silverbird. Yeah. Because it has to have a 4 in there, because we can only get to an even number using G. And so if 11 is going to be an S, we have to get it from F. F can only make that happen if we plug 5 in, but we don't have 5. So 11 can't be an S, right? That's how we think about this. 12, we have to use G, and we would need to plug 3 in, and 3 is a thing. Oops. Ah. $13. I have want to go back to Sidos's idea for counting them, but I feel like I'm gonna get, like, no matter which direction I choose, I'm gonna get stuck somewhere. 13 is 1101, which is not possible. Single zeros are impossible. Okay. Yeah, and so with the logic I was using, we would need 6 to plug into F, and we don't have 6. So, yeah, I agree. 13 is not a thing. 14 is not a multiple of 4. 15, we would need 7, and we do have 7. F of F of F of F of 0. Close, 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 close. 15. Oops. 16 is 4 times 4. So G of F of 0. And so the size of S here is 4 plus 1, 2, 3, 4. 8? Interesting. Are we adding 4 or are we multiplying by 2? It's the sum of Fibonacci's? Really? Right, depending how you want to start it, Fibonacci is 0, 1, 1, 2, 3, 5, 8, 13, 21. So what sums are happening here? Like a 3 and a... I don't quite see that in bucks. Denote h of n to be the number of feasible numbers between 2 to the n plus 1 and 2 to the n plus 1. We can find a recursive relation for h. Can we? Oh, okay, wait, yeah. That's what I think where I was going with this by finding examples. Should go on a number of digits basis. Start with 11 digits and move down. So permutation functions then do a sum to find the total number. Yes, Eidos, I do like that approach too. I think I got it by noticing that the number of acceptable k-digit binaries is equal to the sums of the number of k-1 digit and k-2 digit binaries. Oh my god. Set as a solution is a double summation. Yeah, it still feels a little bit difficult to count all those cytos. That's why I'm kind of hesitating, because you have quite a few different cases to think about for each case, I feel like. There's a pattern eventually? Okay. Yeah, because every number starts with 1. And if you fix the number of digits, then you have to worry about double zeros taking up 2 spots. Okay, you know what? Maybe we should just do that. Okay, well, we're going back to binary. Acceptable binary numbers by digits. So 1 digit. The number 1 is acceptable. 2 digit. Only 11. It does come out to 144? Okay. 3 digit. We can do 100. We can do all ones. This does 1, 1, 2, 4 digit. And I'm saying distinct. So I'm not counting 0, 0, 1. Those are all the 1, 2. This is Fibonacci so far, right? No way. Wait, that's too many digits. This is acceptable though. Wait. Yeah, the zeros have to be paired, right? We concluded that. Cytos and Papadori are both asking how Fibonacci showed up. Very randomly, it seems. So for 6, I mean, I don't know if there's even a point in working on the 6-digit case, but I'm doing it. I dropped one off. 1, 1, 1, 1. 2. Wait, no. So wait, this is 1, 1, 2, 3, 5. We would expect 8 in 6 digits. So 1, 2, 3, 4, 5, 6, 7. I'm missing 1, right? All ones? Okay. That's so funny. And so it's the answer that we want then is the sum of the Fibonacci numbers. We're doing a 10-digit number, right? Wait, did I say it's 10 digits or 11 digits? 1024. That looks like 10 digits, right? 2 to the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, yeah. Wait, that's 11 digits. Okay, 11 digits. One plus 1 plus 2 plus 3 plus 5 plus 8. So that was for 6. 7 is 13. 8 is 21. 9 is 40. 33. 34. 10 is 55. 11 is 89. Isn't that too high? Aren't I over? F of n plus 2 minus 1? Oh, interesting. This is more than 144, though. Why am I wrong? Oh, because this is a 1 on the end, right? We're not counting all 11-digit numbers. We're only counting one 11-digit number. Plus one 11-digit, right? Okay, quick math. 89 plus 1 is 90. 90 plus 21 is 111. 111 plus 13 is 124. 124 plus 8 is 132. 132 plus 5 is 137. 137 plus 3 is 144. Plus 4 is 144. I think I said 144 twice, but I think this actually comes out right. Okay. Yeah, so Papadoria, we need to go back and actually explain this problem. I am still kind of stunned that this is a valid way to do it. Wow, this is... This is crazy. How do we explain this problem? I think Silverbird maybe had an idea for keeping it in base 10. I don't know where to go with it though. You either apply G to 4 digits to get 6 digits or F to 5 digits. I think there's multiple ways of figuring this out. The one that Femblock suggested here initially of using binary numbers is how we did it. So the important thing, or the reason why binary numbers are convenient here, is because F and G are very simple to think about in binary, if you're comfortable with binary. So if you take a binary number, double it, and add one, you're just appending a 1. So if you plug in the binary number 10, if you double 10, that becomes 100. Because that's how multiplying by 2 in binary works. And then if you add 1, you get 101. And so that's why all we've done is take that 10 and put a 1 on the end. That's all F is really accomplishing. G, if we do the same example with 10, if you multiply something by 4, that's just 2 squared. Multiplying by 2 in binary is really easy because you just add on 0 twice, so 1,000. And that's important because we can start with the number 1 because we know that 1 is in S. And we can make any number, we can put we can take this 1 and we can add as many 1s after it or double zeros after it as we want. The only thing we really can't do is put a single 0. There's no way to get just that 1 0 there, because the 2 rules we have to work with like just don't allow it. So what the problem has become is count every binary number. Actually, we've only done part 1 of this question, haven't we? There's a part 2, but count every binary number up to 1024 in base 10 or 10 million in binary. That is acceptable. And so that can be tedious, but we can just start with doing simpler cases with just a few digits and see if there's a pattern. So there's only one one-digit number we can make, and that's just 1. My engineering study vlog. Yes, I can help with that. Feel free to post it there in chat, or if it's easier to put an image, you can put it in Discord. I'll type that too. Oh, I see that you're already in the Discord. Awesome. Okay. Sorry about that, Papadoria. Okay, so we know that 1 is an acceptable one-digit number. For 2-digit numbers, we only really have one option, which is to append a 1. Because we, oops. If you start with 1 and you append 2 zeros to it, that's a 3-digit number. So our only real option, we only have one option for 2 digits. For 3 digits, we start with 1. We can now add 2 zeros after it, or we can put 2 1s after it. So that's how I got the 2 there. And then for 4 digits, that's where it starts to get a little like harder. I thought of it as just like you always start with a 1 and then you have 3 slots to work with. You can have a 00 here, or you can have a 00 here, or nowhere. So I kind of worked around where my 00s were. And as soon as you have 1 1 2 3, you should already be thinking Fibonacci. I went 2 more cases just to make sure, but you can be pretty sure from here that it's Fibonacci. And because these are all acceptable numbers, we do have to go through and add up all the way down the line. But you don't have to name the actual numbers. We just need to know how many there are. And so we can just do what I did down here and figure out what the next Fibonacci numbers are. There is a little bit of a trick where we want every number that's 1 digit through 10 digits, but we're stopping here at 10 billion. That's an 11-digit number, and we only want the one 11-digit number. So that's why I added the 1 on the end here, because we don't want every single 11-digit number. We only want one of them. So I hope that explains how to do at least part 1 of this problem, Papadoria. The Fibonacci sequence was very unexpected for me. It's not something that I thought we would get. And Cytos is asking the hard question, which is, instead of 1024, what about an arbitrary natural number n? Okay, yeah, and so Papador is asking that too. I mean, it does eliminate 0. You could get 0, I guess. I I don't think 0 would cause you issues, though. Oh, wait, would it? Maybe if you included 0, that might cause an issue. Because you could do f of 0, or you could, oh yeah, you could get every single natural number if you include 0, right? Just by continually using f, I think. Or like, if you start with g of 0, you can put as many f's on the outside as you want, I think is the issue. And that would give you every single natural number. It wouldn't? Okay, well, I might just also be stupid, but... Oh, wait, you're right. You just only get 1, right? Or only odd numbers? I don't know. You might be right. I don't know. We've been over this. You're probably right. How many positive integers less than or equal to n? How can we figure out? Okay, sounds good. Okay. My engineers, I'll work on that once we're hopefully through this problem. Oops. So can we take Bob? Great news. What's the news? Cow problem 2 just dropped. Oh my god. I can't believe it. Keep it the hell away from me. So this is a question that Papadoria asked up here in chat. We worked out part 1. Oh, no, what did I do? We worked out part 1. It's actually the sum of the Fibonacci sequence. It's kind of crazy. And we're working on part 2 now. Oops. And so how we did part 1 is right here. We brought it into binary and just counted each of the acceptable numbers. And it turns out to be, if you look at it by digits, they increase, like, or they follow the Fibonacci sequence. Exactly, yeah. You worked that out quick, Bob, yeah. I have no idea for an arbitrary natural number, though. um, I'll paste the text in chat as well in case anyone just wants to have a copy of it. Um, I assume we could modify this in some way. Like we have to figure out where to cut it off. I don't really know how you do that algorithmically though. We only need to worry about the most number of digits. You see, okay, yeah. So like if we can always, yeah, okay, I see what you mean, Cytos. If we're given a binary 6-digit number, we can reuse our same work for 1 through 5 digits. So we only need to worry about how many 6 digits to include. Yeah, exactly, Bob. And so how can we work out that piece of it? And I guess we probably, I know that Cytos put a formula for the sum of the Fibonacci numbers, but I wonder if there's different ways of putting it. Need to articulate it better. It's nearly all the 2 to the k solutions except for the last case, where you only count some of it. And that's the part that I'm not quite sure of. Apparently, the Automod thinks that n equals 19 is related to race, ethnicity, or religion. I can't believe you, Bob. Talking about race, ethnicity, or religion. Seems like n equals 19. 1, 0, 0, 11, so solutions. Huh. Coming. Oh, really? The reason I was looking this up is because I don't know where they start the Fibonacci sequence from for this indexing. Oh. Huh, that's kind of funny. it's not quite like the binary thing, but I think it probably comes out to be the same thing. Oh yeah, you don't have to apologize. My engineer study vlog. Um, I do play chess sometimes. I kind of rage at it though, so I don't play it a lot. Okay, you know what? I guess we could just test it. If I'm worried about it. Someone did say chess over in the YouTube chat. Yeah, Cytos is the goat of chess. Magnus Carlsen. I didn't know you were a fan of math. One people, yeah. Bob won't let that stand. N plus 2 minus 1. Um. Oh wow, it's happening. A big fan of. Yeah, I'm a big fan of Magnus Carlsen. I don't know how to do part two. I think I'm stumped. Like, I don't know if these numbers are evenly spaced. Like these numbers. I don't know how you do it. For an arbitrary n. I have my engineer's study blog is getting in there too. It's not like Bob and Cytus are challenging each other first, but I think there will be some chess happening. It seems. Oh, is that like the spectate link, or is that the actual join link? We're currently playing. Okay. Oh wait, maybe I shouldn't show it. I won't show it on stream in case. Yeah, there's an eval bar. I'm not gonna actually show it on stream. Actually, I could turn the eval bar off, can't I? Um, there's nothing else on screen showing what the evaluation is, right? Okay. That's the game that's happening. And I'm just gonna keep this up while I'm still like thinking in the background. Papadori, I might just be stuck on your part two though. And I'm thinking I might at least switch problems for now. Higher rated than you? They're higher rated than me. Oh my god. What is happening here? Yeah, same Papadoria. I want to see what's going to happen with this game, but I'm going to work on my engineer's study vlogs question. And then if I have a thought for yours, I'll come back to it, but I'm not sure. Yeah, they both have pretty good ratings. But Saito was saying they're the GOAT. And I feel like the GOAT wouldn't be rated 1600. It probably is just this time control or something. And relax your mind while playing chess. Yeah. Hey, Zach. It's a showdown between No Pro Bob and Saitos. It's nice. I get to sit back and relax and not like hang pieces in really stupid ways. I did turn off the engine evaluation, but honestly I don't even know. Like I have no clue who's better. Oh wait, I mean, there's a material difference in there. Oh, it's not looking good. Let's see. Is there a stalemate trick? That's Saitos's only hope. Oh, the double queen. Oh my god. Bob was playing with his food. There we go. GG's. Bob wins. Oh, they're the instant rematch. Okay, we'll watch this too, and then we'll do the differential equation. We're taking over the stream, dude. I'm here for it. Well, actually, I can also look up. So, you want to do undetermined coefficients or variation of parameters? Undetermined. I mean, neither of them are that bad. Just gonna get that up to have it ready. What's this looking like? Even material. God, I would be a terrible chess commentator. I'd be like, there's definitely pieces on the board right now. Ooh. Pushing that H pawn. Harry. Oh, and oh, what's the A pawn? I don't know if the A pawn has a name. Cannot play chess. You're just under 1,000. Oh. I mean, it's possible to do odds, but yeah. Oh, what's happening here? Really? Takes with the pawn. I didn't really think about it. That seems like a good position to like go back and think about more. There's a lot happening. This is like a complicated one. Ooh. The sack? Oh my god, wait. I don't know what's happening. That might have been. Oh, nice, Bob. I got it. I was thinking you should I like right here, I was so certain that like pushing the pawn would be better. No pros the hyper goat? How do you see the actual lines? Oh, I don't have the freaking membership. Freaking chess.com, man, wants you to pay for everything. If I push, he goes king a and is relatively safe. Oh, okay. The eval bar still like loves the position. Okay, I didn't think about this king move, I guess. It does put a damper on the attack. It's not as obvious to me. Nice. Man, that makes me like, want to put up like have like a viewer like chess tournament. I mean, oh yeah, I mean we're just watching Cytos and Bob play here. Like have like a viewer chess tournament and put up like a $20 prize fund or something. That could be fun. Okay, so a little digression there. We are going to look at my engineering study vlogs problem. And we have a non-homogeneous second order differential equation. Y double prime plus 4y prime plus 4y equals e to the minus 2x. Okay. You always play the sodium attack. I noticed that chess.com called it that. I have never heard of it. And so you say undetermined coefficients or variation of parameters, so maybe I'll just choose one. Would soda be called soda because it's made out of sodium? Maybe. I don't know. So to approach these, I don't remember if it's an assumption or a fact, but we say that the solution y is equal to the homogeneous solution plus the particular solution. And so let's work on the homogeneous first, because that one's a little bit easier. We consider the similar differential equation, y double prime plus 4y prime plus 4y is equal to 0, and we solve this. We normally put h's here, right? And so there is a characteristic polynomial, I think it's called, for this, which is x squared plus 4x plus 4 equals 0. Everybody says x and y, but never how true, Lucas. 1 knight a3 is the same text as na3. Oh, okay. Oh, really? They gave us imaginary roots here? No, it's not imaginary. It's x plus 2 squared. Never mind. A repeated root. That's interesting. Yes. Characteristic equation. This is differential equation, Zappin, yeah. And so we get x is equal to -2 with multiplicity 2. And I think that means the homogeneous solution. Oh my God, Zappin. Every time I stream, are you going to try and cram a different semester's worth of studying into 2 weeks and ask me to justify it? God damn it. 80 weeks. That's what I sentenced you to. I think our homogeneous solution is C1e to the -2x plus C2te to the -2x. Sorry, x. Differential equations should always use t. I hate it when they don't. Let me confirm that, but I'm pretty sure that's our homogeneous solution right there. The particular form... It might just be exponential. You might not need the x in front. Hey, Raven. They should use kappa. True. Finally, I know. Okay, good. I'm right. Okay, so why is my camera out of focus? Is that better? Or was it out of focus before? It's hard to tell when it's in the OBS preview because it's so small. Okay, so I'm kind of leaning towards undetermined coefficients because I remember that better. Because our function on the side is just an exponential like this, I think we assume it's a constant a. Oh, what? Yeah, Bob, you have you have the x squared there. I feel like we don't need x squared. Yeah, I don't think we need it. Let me confirm this was their problem. Yeah. Okay, so coming over here for the particular, we're going to basically, we're calling it a guess, but it's a very good guess. Guess that y sub p is equal to some constant a e to the -2x. And basically, we can take this and plug it into the differential equation that we're given and figure out what a must be. And we're going to get a valid answer, so that means that this is a valid solution. R equals -2, yes, and complementary solution, but I did not get it. Okay, so yes, you're with me so far. And Raven, that's a very good question. The x squared is necessary? Oh, it's that... I remember, yeah, you're right. I forgot. This is that really tricky case. Okay, I need to back up. This comes up anytime the exponentials match. But yeah, with repeated roots, it makes it even trickier. Okay, so... my engineer study blog, the mistake I made is that the function e to the -2x happens to show up in our homogeneous solution. It actually shows up twice because we have e to the minus 2x and x e to the minus 2x. This is a really special case where when we go to guess something for the particular, we need to make sure it's different from what we did in the homogeneous part. So e to the minus 2x is taken, x e to the minus 2x is taken, and so kind of the next natural thing is to do x squared e to the minus 2x. It's a really weird thing that I don't fully understand for myself. Yeah, Bob. But this is what we guess. And the reason why is because of how our homogeneous solution looks. Okay, and so now that we have this for our guess, we want to plug it in to the original differential equation. You got it? Okay, awesome. So we need to find, we need to take the derivative twice. So we know to plug it in here and here. So y sub p prime, we have to do a product rule. A 2x e to the minus 2x minus 2a x squared e to the minus 2x. Messy handwriting. And let's write that as 2a. And then y sub p double prime is something that's really annoying, because we have two product rules now. 2a e to the minus 2x minus 4ax e to the minus 2x minus 4ax e to the minus 2x. That's interesting that these two terms match. Plus 4ax squared e to the minus 2x. Is that right? I think we're good. Let's simplify that a little bit. Minus 8axe. This math problem is brought to you by Axe Body Spray. Use an entire can of it each day. That way you don't have to shower. Okay. Now we know what to plug into the original differential equation. So y double prime is the thing we just wrote. That's really annoying. Actually, let me copy. Paste. Okay, this is going to become 2a e to the minus 2x minus 8ax e to the minus 2x plus 4ax squared e to the minus 2x. This is all the y double prime term that I just wrote. Now we're going to do plus 4y prime. It was an add the entire time. Imagine like I get someone in chat to give me a math problem that, you know, just looks like a brain. It's like, surprise, sponsored stream. I'm plugging in this right here. I don't think science can replicate the smell that comes out of a high school locker room after PE lets out and all those sweaty teens are putting on way too much Axe body spray. I missed an X. Two ax e to the minus 2x minus 2ax squared. Okay, now we're good. Okay, That's the 4y prime. Now we have to do 4y. We need 2 lines for this. Plus 4ax squared e to the minus 2x. Oh, it's not TTS, but it just plays the same as like a follower alert. Okay, that is all equal to the original thing, e to the minus 2x. Okay. Now we have to solve this for a. Now, we can divide out e to the minus 2x, and I see you're pointing that out too, so that's great. Let's divide e to the minus 2x out. Our lives will be simpler. So the same bits from the start of 2024. So we divide out e to the 2x, we get 2a minus 8ax plus 4ax squared plus 8ax minus 8ax squared plus 4ax squared equals 1. Okay. Now, we have to group things by what degree of x they have. Well, I mean, let's just like group like terms. So minus 4ax squared minus 8ax squared plus 4. Oh, the x squareds go away? That's convenient. That makes sense, right? We should only get one result for a. Minus 8ax plus 8ax. Really? That's so convenient. Okay. So everything goes away except for 2a. So a is a half. And so I think that means our particular solution is y equals 1/2 x squared e to the minus 2x, taking what I wrote up here and plugging in a. So all of that means that our, oops, y sub p. The entire solution for this thing is the homogeneous plus particular. So y is equal to c1 e to the minus 2x plus c2x e to the minus 2x is the homogeneous, plus the particular 1/2 x squared e to the minus 2x. That's the solution. So yeah, that's a very tricky differential equation, my engineer study vlog, but I hope this makes sense. A is minus a quarter. Oh, great. I'll let Wolfram Alpha be the judge of that. Let's see. I would definitely believe that I made an arithmetic mistake somewhere. But let's just like verify. 4y prime plus 4y equals e to the minus 2x. Ooh, Wolfram Alpha agrees. Or like Wolfram Alpha agrees that it's 1/2. So yeah, my engineer study blog, I'm not sure what to tell you. I think I did it right. Where could I? You know, we could we can check that solution. We can check both of these solutions. That's what we can do here. So if A is minus a quarter, let's try and check this. Well, I get a positive 2, though. Do you have one problem we can do after this? I don't, if you don't have any people waiting in the queue. There's no queue. There's still the second part of Papadoria's question up there, but I don't think I'm going to make any progress on it. So I'm happy to look at your problem after. If y sub p is this, we should be able to plug it into the original differential equation and get a valid answer. So let's try that and see if something breaks. I think that's our double prime. Okay, so let's take this bad boy, copy it, paste it, and then we need 4y prime, which is this bad boy, copy it, paste it. Oops. Plus 4 times the original y sub p minus 1/4 x squared e to the minus 2x is equal to e to the minus 2x. So we're just going to try and check if this is a valid equality here. So let's start by simplifying things a little bit. 1/2 e to the minus 2x. We'll group these two terms. 2x e to the minus 2x minus x squared e to the minus 2x. Now we'll distribute the 4 inside the parentheses over here, plus 2x e to the minus 2x plus 2x squared e to the minus 2x, and multiply those two numbers, minus x squared e to the minus 2x equals e to the minus 2x. Okay, so what do we get here? So looking at the x squareds, minus x squared plus 2x squared minus x squared. So the x squareds do cancel. 2x is 4x. And then we get that with no x. And so yeah, here's the issue. We can factor the e to the minus 2x out from the left. And this statement is not true unless x equals, wait for it. There is one value where this is true, but it's not true in general. And it has to be true for every x, or as many as we can get. Um, so I think I've proven that a equals minus a fourth can't be right. And so if the book or whatever is saying that's the answer, I think the book made a mistake. Or I copied the original problem down wrong. One of those two things. Yeah, I think so. Putting solve the world's hardest problem, earn yourself 1 mil. It's a pretty good plan. I hope that the techniques here all made sense at least. That's the more important part. But I think the book must be wrong there. It's just a different A. I mean, the final result should still be the same though. Does the book give the final answer? C1 and C2 are arbitrary constants, right? That's true. Um, does the book say what the final function should look like? Like, does it give like this version of the answer? Or is that where the minus 1/4 is coming from? Hmm. Yeah, because Wolfram Alpha agrees that this is that my answer is right with 1/2. So unless there's some weird misunderstanding, I think that the book just made an error. Bob, what's your question? You might wrap up with that. Managing your study vlog, I can't think of anything else to say about the problem, but I think it's just a book mistake there. And for a good journey studying math, hopefully, yeah. Uh, no, my engineer study vlog, the book was just wrong, I think. If you want, you can post you can post a picture of what the book is saying, but I think it's just wrong. I wonder if Bob is here. Let me type Bob's name. It is late. Actually, it's super late for Bob, so I wouldn't blame him if he fell asleep. I wouldn't use ChatGPT. I mean, I get 1/2 when I do it by hand. Wolfram Alpha gets 1/2. And if you try plugging in a equals a quarter to the original differential equation, it just doesn't work. So I'm not sure what else to say about it other than I really don't think a equals a quarter is right, unless that's some different a or something and the setup was different, but I don't know how it would be different. Oh, Bob, what's your question? Or what's your fun problem? Okay. Yeah, thanks, my engineer's study log for the question. Sorry that it's not a satisfying answer, but that happens. All right, let's see. Okay, so prove any subset A of S with n plus 1 elements. Okay, so at least half the set plus 1. Has 2 elements in it such that one is the divisor of the other. Well, that feels like and it feels like an argument where we must have at least, if we have two or more even numbers, then it's trivial. I haven't even read the simpler part yet. If we have one even number, then something, and we can't have zero even numbers because of the construction of the set, right? Best beard on Twitch. Can I touch it? You can touch your screen, or my beard is. That might, help. For now, yeah. You got to get back to streaming, Bob. As soon as you said you weren't putting on doing more math, I was like, oh, I'm changing my tag. Can you come back? You're reclaiming the title. You can try. Okay, so we can make the claim S contains n even numbers and n odd numbers. A must contain at least one even number by construction. If A contains at least two even numbers, then one even number must divide the other. I should be typing this, but I'm in too deep now. I can do so many things you wouldn't know. Okay. It's got 180 coffee beans. Hell yeah. Giving you a head pat right now. Thank you. 51.8K, I'm ready to gamble. 4 and 6 is a counterexample. God damn it, Fembox. Okay, that blows up my argument. You're right. Maybe what I said, the first sentence might still be, or the first two sentences might still be helpful here. I should just type this. So, I mean, maybe what I put isn't even all that helpful. Twitch math community is small, that I see everyone here in other math streams, sometimes new math streamers. Yeah. It's pretty niche, but like the people who are in the niche are very like dedicated to it. Like I think what we have here is really special. This problem is really hard if you don't know the trick. Oh, good. Is it like a theorem that I wouldn't know? Uh, it's from the book. What book? I'm just thinking of the Jungle Book, but I don't imagine it's that book. Or maybe the Bible, but I don't think it's in that book either. Jed has an idea? One reason I found out about y'all is by searching math on Twitch. I found Obi streams, and from there, Zach, and so on. Oh, nice. Yeah, that's how a lot of people find us. Just like, you find one person and we spread the word. Two n is divisible by 1 and n, both of which are an s. Similarly, 2 times n minus 1 by 1 and n. Christians are co-working category. Oh, yeah. Paul Ardo's claim there are proofs from the book, which are such beautiful, simple math proofs. It's like a godsend. So some people made the book by that idea, and its problems in it. Oh. I think I can see intuitively what you're saying, Jed, yeah, which is even in the worst case scenario, let's just take the set 1, 2, 3, 4, 5, 6, 7, 8. The worst case scenario is choosing like only the upper or only the lower part. And I think the point that you're making is that no matter what, you can look at one of these higher numbers, in this case 8, and know that it like half of that number. I don't know if I'm phrasing it, but every number in the actual upper half is constructed by, well, not every number. Half the numbers in the upper half are twice of a number in the lower half. And so if we take, oops, I don't know why I just undid. If we choose n plus 1 things, we're forced to choose at least one of these numbers here. Well, Okay, wait, yeah. If I choose the first 4, I have to choose one of these. Oh, what if I choose 1? Well, 1 goes into everything. Okay. I have to choose one of these, and no matter which one I choose, it divides any of these over here. In the case where I choose 1, it divides all of them. I can choose all the primes in the last n, and the rest in the first n. and then you have a problem. So you're saying if you choose 5 and 7, and then presumably you would be forced to take 2, 3, and 4. Sure, yeah, that's a problem. We're still saved because of 2 and 4. But yeah, the argument that I just made wouldn't quite hold, would it? Thank you, Hardlocked. 55 plus 55. It's very true. Oh, yeah, no worries, Hardlocked. It was like a last minute thing. I figured I'd send you one in case you happen to be on. You also don't like Jed, that's fair. He does stay in the van a lot. Walks out. Sorry, Jed. Given any subset A, not construct A, yeah. I don't know. Like I'm kind of I don't see a more elegant way than going into cases. I based on how you're presenting this problem, I assume there's some really elegant way, but I don't know. I keep wanting to consider cases. I thought I had something I could say if the odd number is prime. And well, then God damn it. I want to figure out what the trick is. There's no way this is the trick. Whereas Erdos asked one of his students this question during dinner. At the end of the dinner, student gave the answer. Erdos hasn't forgotten the answer in 30 years, something like that. You're going to bed? Oh, dang. All right. Well, get some sleep then, my engineer study blog. Thank you for hanging out and for asking the question. Yeah, just give me the answer. I don't think I'm coming up with this on my own. That's not how like um struggling over it for a long time. So like I keep wanting to go into cases, but it's not really working. Okay. M times 2 to the A. Sure. Since numbers go up to 2n, M can be from 1 to n. Sure. No? M can be as high as the prime number before 2n, right? Or it has to be. M is an odd number. Oh, there. Okay. You can express any number in the form of M times 2 to the A, where A is 0, 1, 2, dot, dot, dot. Since numbers go up to 2n, M is an odd number. And there are at most n many of those M's. Since there are n plus 1 numbers, one of the M's have to match up. Okay. Let me like type this up in my own words. M times 2 to the A. Where A equals 0, 1, 2, dot, 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 and M is an odd number. Many possibilities for n. Since the cardinality of A is equal to n plus 1, there must be at least 2 elements of A with the same M. Okay. I would not have thought of this, so I'm glad you just told me. That is way more elegant than anything I was trying to do. Yeah, right. I didn't say that part, but it's trivial. Like mentally, that's right. What I did in my head. Say K A to the A1 K A. No, I'm not gonna phrase that right, but I see the point. Okay. That is a neat little proof there. Hey, Reaper. Hope you're doing well. Dang. Okay, yeah, I'm just like thinking about it, but that is like annoyingly simple. um yeah. It feels like it should take more work. I'm glad it doesn't though. Um okay, so for Papadori's question, I just don't know about the part 2. I'm calling it quits on that. And I was working on a physics problem, but I think I'd rather just wrap things up for the day, I think. You can set the bounds. Oh, yeah. You can definitely bound it from above. Yeah. And below. I don't know how you do it exactly. That seems like kind of really difficult. Um, but yeah, I think we're gonna wrap things up here for the day. So, oh, why did that get hidden? Oh, that's annoying on the YouTube chat. Oh, hey Spectry, you're catching me right at the end. No, no. Actually, Zach got first. He eats it to I pie. Um, so yeah, I'm gonna cut the YouTube stream up here. So people on YouTube, thanks for being here. I'll see you later.